Okay, let's continue. Now lecture 3b, again application of Lie bracket, Euler Lagrange equation. It's better to write our Euler Lagrange equations. Now, item 3, continuing. You see, we will use the principle of least action, which is placed in the definition of the general Einstein theory. You see, Einstein field equation. That's a definition. Okay, that's a very important concept about the principle of least action. Now, I just copy from the final of this lecture 3a. This is the equation here, the integral. Recall from calculus that d of dx, u and v are function of x. So du dx v plus u dv dx. This is a product rule, or Leibniz rule. Now, you see, if you multiply by dx, this leads to differential of uv, v du plus u dv. Now, the integral of the left-hand side must be equal to an integral of the right-hand side, which are right here. But d of uv is exact differential, which the integral leads to uv. You see, that's the exact differential. So now this left-hand side is equal to uv at x2 and x1. This is in this case we will apply, okay, this integral by parts just on this integrand here, just on this term over here. You see? So use integration by parts on the delta q dot I, you see, term. So I will apply this over here, okay, to here. Now, this is partial L with respect to q dot y, delta qi dt. You see, that's analogous to this uv x1 and x2. But now, it's T1 and T2 minus, you see this integral left. Now, the boundary term vanish due to the fixed endpoints. So I set this is equal 0. So this integral here is minus integral of T1, T2 of this integrand of there. That is clear now. So then this leads to this integral over here, okay? If I combine this term with this term over here, you see? Now I can write this integrand here, the integral of this is equal 0. Because the end points, fixed end points, you see, so they does not move with the time. So then from here, since delta qrt are arbitrary, the integrand must vanish. So I take this integrand here and write over here is equal 0. This is called Euler Lagrange equations. Attention now, qi and q dot I is equal 1 to n. They are called generalized coordinates, qi. You see, this is qi. And velocity, generalized velocity, this is q dot I, respectively. So that's it. That's the Euler Lagrange equation. Now I will define from the Lagrangian the Hamiltonian and show using Legendre identity that the Lagrangian and Hamiltonian, they lead to the same physical problem. You see, that's very important. I'll show this as an example, okay? Just for you to see that the Lagrangian and Hamiltonian, if I use Legendre identity, this leads to the same solution. This I will show applying to a physical problem. Okay?